Hi everyone, welcome back for another video. So in this video, we're going to be exploring another great idea in mathematics. We'll be talking about parallel and perpendicular line. Let's get to it. So before we get to doing examples, let's talk about what does it mean for two lines to be parallel. So let's look at these two lines. So if you look at the purple line and the green line, these two lines are parallel because they have same slope. They're going on the same direction, but of course they have different intercepts. So using that idea of having same slope, we're going to do some examples on how to compute parallel lines. So here's our first example. Find an equation of a line that satisfies the given conditions. We want the line to go through the points 1, -2, and parallel to the line x plus 2y equals 6. So in order for the two lines to be parallel, they must have same slope. So the slope, which we're going to call it m, they must be the same. So first we're going to rewrite this line in terms of y equal mx plus b, so we can identify what the slope is. So let's go ahead and subtract x from both sides. So we have 2y is equal to -x plus 6. And then we go ahead and divide both sides by 2 to isolate y. So we have y is equal to negative, you can write it as 1/2 x plus 3. So there you have it. This is what we call the slope, m. So we know our parallel slope is going to be -1/2. We want it to be the same slope. So that means the equation that will go through the point 1, -2 will be the following. So we have the point, which is 1, -2. So let's call the point x1, y1, and we have our slope. So let's use the point slope form to write the equation of the line. So we're going to use y minus y1 is equal to m times x minus x1. That's the point slope form. And plug in x1, y1, and m into this equation. You have y minus -2, that's y1, is equal to m, which is -1/2 x minus 1, which is our x1. And then you can just rewrite this nicely by removing the double negatives on the left side. We have y plus 2 is equal to -1/2 x minus 1. So there you go. That's the equation of the line in point slope form. Let's take a look at another example. So here's another example. We want to find an equation of a line that satisfies the given condition. So we need a point and we need the slope. So the slope we're going to borrow from the given line, and the point is going to be this point right here, y-intercept. You can always write y-intercept as a pair of point. So y-intercept is when x is equal to 0. So this would be 0, 1. And the slope we're going to borrow from this line, but we're going to rewrite it as y equal mx plus b form. So we're going to go ahead and subtract 2x and subtract 7. So we have 3y is equal to -2x minus 7. And then we divide by 3 on both sides to solve for y. So we have y is equal to -2/3 x minus 7/3. And that's our slope. So we want it to be a parallel slope, so we keep it the same, -2/3. And then the points we have, we can label them again, x1, y1, and then using the point slope form, we write out the equation, y minus y1, which is 1, is equal to m, that's -2/3, x minus x1, which is 0. And then just rewriting it nicely, we have the following equation, y minus 1 is equal to -2/3 x, because 2/3 times 0 is 0. So that's one way we write the equation of the line in point slope form. Now, if you just want to move things around and write it in another form, you could also do that. We can add 1 to both sides. You have y is equal to -2/3 x plus 1. So that would be the representation of the same line in slope-intercept form. Okay, let's try another example. Let's try this one. So find an equation of the line that satisfies the given condition. So we want the line through the point -2 and 7 parallel to the line x equals 1. Okay, well, what's the slope for this line? Well, if you recall, a vertical line has a slope undefined. So this is a vertical line. So the slope is going to be undefined. So that means our parallel slope is also going to be undefined because we want them to have same slope. So that means the line we're going to come up with will also be another vertical line, but it's going to pass through the point -2, 7, which means the equation would just be x equals to -2, the x coordinate of the point. So that would be the line that's parallel to the line x equals 1. All right, now we're going to take a turn and talk about perpendicular lines. So here I have two lines, the green one and the blue one. These two lines are considered to be perpendicular because their slope is negative reciprocal. So if you look at this point that they go through or intersect, is the point 0,3, and that's where they form a 90-degree angle. So another way to think of two lines are perpendicular if they meet at a 90-degree angle, or you can say their slope is negative reciprocal. So using that idea, let's do an example. So for this example, we want to find an equation of a line that goes through the point 7, -5, that is perpendicular to the line passing through the points 2, -7 and 2, -5. Okay, so we want to find the slope of the line that connects these 2 points. So the slope is given by the formula y2 minus y1 over x2 minus x1. So let's go ahead and label the first point x1, y1, second point x2, y2, and plug them into the slope formula. We have -5 minus -7 over 2 minus 2. Well, so on top we get positive 2 over 0. Well, you can't have 0 on the denominator, right? Oops. So that means the slope is undefined. So the slope of this line is undefined. So if I were to do negative reciprocal of this, it would be, so the perpendicular slope is negative reciprocal, so it would be 0 over 2, which simply means 0. So the perpendicular slope would be 0. Now using that slope and the point we're given, 7, -5, we can write out the equation of the line. So using the point slope form, y minus y1 is equal to m times x minus x1. Plugging in these points, y minus -5 is equal to 0 times x minus 7. Well, of course, all of this is 0. So the line you're really looking at is y is equal to -5. Another quick way to really find an equation of this line, since it has slope 0, you know you're looking at a horizontal line. So you can just take the points you're given and write the equation as y equals to the y coordinate of that point, -5. So two ways you could have approached this problem because of the slope happens to be special. It's the 0 slope. Now let's take a look at another example. So here's another one. We want to find an equation of the line passing through the point 2, 7, perpendicular to the line y equals 1. So if I want it to be perpendicular, well, y equals 1, that's a horizontal line. So that means the slope of this line is 0. So if we want it to be perpendicular, that means we're looking for negative reciprocal of that slope. So that would be -1 over 0. Well, it doesn't make any sense to have a slope of 1 over 0, but we know what that means. That means we're looking at an undefined slope. So that means we're looking for a vertical line because a vertical line will be perpendicular line to the horizontal line. So our equation would be x equals to the x coordinate of the point, which is 2. So there you have the line that is perpendicular to y equals 1. Now, if we were to sketch these two lines, so let's take a look at a quick sketch on the xy plane. So y equals 1 would be a line that will go through the point 1 on the y-axis. So it would look something like this. So that would be the rough sketch of the line y equals 1. And if we want a perpendicular line through the point 2, 7, let's suppose 2 is here, 7 is here, that point. So a perpendicular will be a vertical line. So we will be looking at this line right here. And the equation of that line would be x equals 2. So they meet at a 90-degree angle right there. So there you have an example of a perpendicular line. I hope you guys found this video helpful. So that's it for this video.